We are live. How's it going, everyone? Pretty excited here
Hello.
today for another good old Tech Friday. It's been a minute, but we are ready to smash it. So I guess without further ado, let's share my screen in a sec, and then let's just smash it. Okay, so today, what we basically want to figure out is how on earth do like people categorize countries? Like, would you say, for example, like Sweden and South Africa are similar countries, or not really? Or like, would you say Uzbekistan and America are similar, or would you say like America and Canada are similar? Like, how do you sort of come up with those things? How did people come up with the notions of like first world countries, second world countries, third world countries, and like, I guess what data can we use to actually come up with those insights? Um, so let's actually take a look at that. And I'll share my screen now. And you guys can all see yourself, right? Inception. Nice. Okay, so let's have a look at this cool data set I stumbled across. I can't actually remember where exactly where it was from, if it was from the UN. But essentially, check here, we got all of the countries in the world, pretty much. Botswana, um, Costa Rica, Cuba, Finland, Ethiopia, a lot of cool ones. Let's see if South Africa's somewhere here. Must be surely. Can someone spot it? Feel like
It's Z,
South.
ZAR,
There we go. Audit over here. Nice,
ZAF,
Jason.
sorry.
So you can see there's all of these columns over here, and like this is how you often get data with like these weird columns. And one of the not difficult but annoying parts is now they give us like the series labels over here. And can you guys see these fine? Basically, the factors we get for each country, there's 19 different things, such as access to the electricity, percentage of the population, what's foreign direct investment, CO2 emissions, inflation, mobile cellular subscriptions. And one of the next things like to be noting straight away is you can see this value is like, for example, a percentage of the population. So this could be 47%. And this mobile subscriptions is also, I guess, sort of a bit like a percentage per 100 people. But then there's also what is the GDP per capita, which is like measured on a completely different scale, right? What is the life expectancy at birth? That's also measured on a different scale. So all of these data points are like measured using different metrics, which is something else that we're also going to have to like think a little bit about why or how are we going to standardize and make a good comparison. So some other interesting ones: population growth, fertility rates, what's the urban population, mortality rate, death rate, birth rate, GDP per capita, based on sort of all these like overarching high level stats based on all of these countries. Just this Excel sheet, we want to like try maybe get some insight into which countries are similar. And basically at the end, what I want to sort of try suss out is like, will this maybe help us to figure out why they categorize countries as like first world, second world, third world, and how can we make those types of assumptions? So it's going to be a super quick one. Stop if you have any questions. But one other thing to note, which we'll come back to, is a lot of these things, such as CO2 emissions, data is also like hard to come by, and it's probably not easy to find like what the CO2 emissions are for every country. So you notice there's quite a lot of blanks in certain places for certain countries. And that's also like, like Guam, etc. You have to treat that pretty carefully with countries. Depending on how you treat that can definitely affect your analysis. I mean, zero is essentially means, I guess, there's no data, which is very different to like 0% of the population have access to electricity. So it's like obviously important to treat those things differently. Okay, so let's just get straight into it. It's super simple. We're just going to run through it line by line. We're going to read the Excel data. I'm going to put everything into a data frame, the variables I like. And then here we're going to show the observations, and that's not super nice. So what I've done is I've actually renamed all the variables to be human readable. And now if you look at this head function just gives you like the first 5 rows of the data frame. We can see the country, Aruba. We can see what its foreign investment is, access to electricity, 93%. Angola, access to electricity, 33%. Albania, 100%. Renewable energy, check this out. So Angola's got a lot higher renewable energy than a place like Albania. CO2 emission. Also, it's very interesting to see. GDP mortality, imports, exports. You can see here on internet use, Angola, 2.8%. I think this data set is from 2013, so it's slightly outdated, just to note, but it's super basically interesting to see all of these things. And then obviously like what the urban population is. You can see again, Angola, African country, typical third world, got those characteristics of massive population growth, lower life expectancy, lower access to internet, much higher death rate. The infant mortality rate is a lot higher. And for those of you who study geography, I mean, you'd recognize this. These are indicators essentially of this. Cool. So, I mean, that's just printing it out. And the next thing I actually do is a little correlation plot. So we'll see here in a sec. Oof, it's dirty. How's that, eh? How's that for a live stream? Our session aborted. Wow.
You're running too many programs.
Yeah, I'm running too much stuff. Okay, let me just quickly stop sharing my screen for a second and like try remove all my everything. Basically, let me just delete my hard drive except RStudio and see if we can come back online. Otherwise, how's everyone's day been so far? All good? Any complaints?
Classic demo here. Not a
Classic.
proper demo without a few hiccups.
No, exactly. Flipping classic. Code's rock solid, man. It's the MacBook that's doing us the disservice over here.
Careful, Jason might tune Mac.
Okay, all right. Let's see if we can come back to this over here. I'm just going to open it up.
Space. It's not like RAM or something.
Yeah, it could be basically any one of above of those, but I'm a bit hesitant to restart my computer now. To check all of those things. It should be fine. I'm gonna just. I think I know what the error might have been.
You can always unmute if you want some background music in the meantime.
Oh, that does sound great.
Was it Chrome?
Yeah, it might have been Chrome. Okay, hold on. Well, now I'm getting warnings. It's just the whole world's falling down because it was such a dirty demo. Now things are just dying. Okay. Give me a second. Do any of you oaks have any questions? Okay, let me talk through like what I'm going to be doing while I run it up anyways. So the first thing I guess I'm going to be doing is remember all of those variables are measured on different scales, right? So we are essentially going to want to normalize the scales. Oh, my computer is mincing.
So
we're going to want to
using unsupervised learning to ascertain some data about correlations between countries. Is that kind of what we're looking at?
Yeah. I'm going to open a project. Hold on, give me a second. I think I know what to do here.
So John, if you wanted to use Python from R, could you do that with some data science libraries?
Yeah, that's true. Definitely. If I wrote this again, I would write it in Python, I reckon. R is quite just like simple and fun, but yeah, no, Python is definitely the sexy thing to use. What we should be using. Okay, but now I think we might almost be in business, guys. Almost in business. Read the sheet. Come on, here we go. He's only gone and done it. Okay, let's get back to the sharing. Sorry for that quick little intro. If you're on YouTube, you can probably just skip that. So lucky for you, unlucky for everyone here who's not watching this on YouTube. Okay, hopefully this is worth the wait, eh? So I'm just going to run back to where we were at. And here we're going to plot our correlation. And if my computer doesn't crash, then awesome. Then we're doing better than we were already. So I guess here we're just looking at a bit of a correlation plot based on the values. Things such as inflation, mobile subscriptions, internet use, etc., things like that. So we'll obviously find that obviously things correlate 100% with themselves. That's why they are one. But generally, yeah, if you have internet use, that generally has quite a high correlation with like urban population over there, right? So this is just interesting. We're exploring the analysis, and like it would be interesting to see what CO2 emissions is highly correlated with. So you see here, you can see GDP and CO2 emissions are pretty highly correlated. So that's like something that's pretty awesome. You can see that renewable energy, is basically not correlated with mobile subscriptions. So generally, the less maybe developed the population. I guess this is just can you guys see the screen that I'm showing here fine? Is this someone unmuted?
Yeah. It's good and it's big enough. It's cool.
Okay, sick. Yeah, so I think this is just like quite a fun thing to basically take a look at and try see which things are correlated. And it's always cool when this stuff sort of just makes sense as well, which is nice, which it does. So this was just, I guess, one of the first things we were looking at while we we're exploring the analysis. And now if we keep going through, it's just drawing the correlation plot again. Now we were drawing a box plot, and like this box plot is for all the values we have in the Excel. I think I closed the Excel sheet because it was dying, but you can see because everything was measured on different scales, GDP measured in dollars. I mean, check how crazy this GDP value is compared to everything else. Like if we were to do like pure numerical analysis and not account for this, GDP would skew all of our results. So essentially what we sort of do is we plotting this without GDP. And if you plot it without GDP, the scale becomes a lot more normal and we can sort of better understand these values. Box and whisker plot, classic one. You have your different quartiles, your mins, your maxes, your outliers. Great little statistical diagram. And here now we do a box plot when we actually scale. You can see we're using this function scale and we're standardizing our data. Now you can see GDPs in line, and with all of our variables, electricity access, everything, when our data is sort of on the same numerical playing field, that's sort of what we actually want before we do our comparison. So one variable doesn't overpower another variable and drown it out. Essentially, the next thing we're doing is actually looking for null rows. So remember we said there were loads of nulls. So I just plotted something here to check how many nulls there are for each country. So you can see Guam, there's 5 nulls. St. Kitts and Nevis, like all of these smaller countries where there's less statistics, there's a lot more nulls. And then basically, yeah, here you can see what the nulls are by category. So imports and exports are missing a lot. Inflation's missing a lot. CO2 emission, that's obviously hard to basically find. Next thing we're doing is setting a seed. That's basically just so our randomness is deterministic.
Did we lose him?
Basically, what bag
John?
Can you guys
just
hear me?
We lost you a little bit.
John, your sound's not great.
Just after you were talking about
My sound's not
setting
great.
the feed. No, I think it's just
Maybe just remove our faces.
No, I think it's fine. I think we
Side?
just lost you for a moment. If we can carry on
Cool.
from where
Just
you
yeah,
said
just shut.
putting the seeds
I
is
didn't say
deterministic.
much. Yeah.
Cool.
Yeah, the seed basically makes us deterministic, and that's because this next part we're doing here is you can actually use a process called bag impute, and this basically is just a fancy way of us actually filling in all of these null values based on our other data, and we'll look at the correlations between other variables. We'll fill.
Oh, sorry, John, we've lost you again.
For all of these missing objects. Otherwise, the other option is you just remove those, those countries from your data set. So it sort of depends what you want to do. Here we've done that. You can see it's finished running. Cool. And now, yeah, you can see everywhere is going to have no null values because we've imputed the missing stuff, which is cool. Right, now you can see we have 0 null values. I was just checking because now we've imputed everything. Okay, Alex, so we're steaming along here. So yeah, first part of the data analysis was essentially our pre-processing, checking what do we do with null values, how do we scale the values so that they're all in the same playing field. And now that we've got nice data, we can essentially start to look at how we would actually build something that's pretty cool. So this first thing I'm running here actually is called principal components analysis. And I think I've talked a bit about it before, but basically of those 19 features like CO2 emissions, population growth, this and that, instead of just having 19 dimensions, like how could we plot something on 19 dimensions? We can't visualize it, right? So we take sort of all the variation in those 19 dimensions and we essentially distill it down to 2 principal components, these 2 dimensions that capture as much of that variation as possible. And it comes up with this graph, which is pretty unreadable, so we won't go into it too much, but it's pretty interesting. It just sort of shows the factors and the different countries and where they sit on the principal components. And if I show you now, I think this next one will hopefully make a bit more sense. I mean, PCA is something really take us a while to explain. But here you can say, what does the cumulant variance explain? So like in all of this data, how much variance is explained by each dimension? If we use principal components analysis, you can see that the first 2 dimensions explain 62% of all the variation. So instead of using all 19 factors, CO2, foreign investment, we could do PC8 and just use these first 2 like features, the first 2 principal components, and that would like already help us deal with 62% of the variation, So that's a way to reduce your dimensions, which is often basically something you want to do in machine learning. But yeah, we'll show you this plot now. This should chuck it in over here. Come on. Now, if my R doesn't crash, yeah, here you can just see like these 2 dimensions, first and second principal components I was talking about. You can see which variables contribute to like the variation of this variable. So life expectancy, mortality rate, birth rate, and variable 2, it's imports, exports, foreign investment. That's sort of what comprises of that principal component. But again, like less the details, that's less what I'm keen to show you about. This is again just a dissimilarity matrix. I think I talked to you guys a bit about this when we were doing the EOS voting set. Now we're trying to look at like, how dissimilar are the 180 countries. And again, I'm going to sort of breeze through this part a bit because it's not as interesting. But basically what you want to do is you want to now, based on this dissimilarity matrix, you look at all of these variables and you see like how similar or dissimilar are these countries. And here I've just taken a random sample of 20 different countries, and this should have shows similarity, or sorry, 0 is is similarity, and this is sort of dissimilarity, 10 over here. So you can see obviously everything on the axis. South Sudan with itself, it's not dissimilar at all. It's the exact same. That's why it's on this axis, and this just shows you like different countries. Australia and South Sudan, if we look over here, it's like massively blue because, you know, we expect Australia and South Sudan to be super different just from what we know in our heads, right? So based on this dissimilarity matrix, which is basically a concept of being able to work out a distance between two countries. What is the distance between Australia and South Sudan? And that distance is calculated basically through all of those, across all of those different features we've talked about. You calculate that, and there's lots of different ways to calculate that. Again, not as important.
In this matrix that you've displayed here, have you only selected a subset of
Yeah. So I just randomly plotted 20 countries. Otherwise, it's like you saw the one before. 180 countries is not really readable in the matrix. So just to get a better idea.
It's randomized. It's not based on any.
Yeah. I just took you check your sample. So from 1 to 138, I just took a sample of 20.
Cool.
Which is nice. And then now we want to basically see if there's some clusters based on this. You know, we want to see which countries are similar, which countries are not similar. And the thing I really want to show you is once we've done the clustering, I want to plot on a map the specific clusters. So you can see I'm using k-means nearest neighboring, which is a type of clustering algorithm. And we talked a bit about this, I think, when we did the EOS voting. It's basically you want to cluster into groups and see how similar these different groups of objects are. So we want to see how similar these different countries are. You can see these are our clusters, and these dimensions it's plotted on are actually the principal components. And I mean, this isn't super readable in this format. So what we're actually going to look at and show you is, okay, so this is quite cool. So this aggregate here shows you for the 3 different clusters what the average values are in each variable. So cluster 1, super high electricity access, foreign investment is really high, renewable energy is actually a lot lower, CO2 emissions are really high, inflation's lower, 123 mobile subscriptions per 100 people, internet use over 70%, lots of exports, also quite a lot of imports, massive GDP compared to the other 2. Mortality rates is a lot less on both sides. The birth rate's a lot less. The death rate's lower. The mortality infant rate's lower. Life expectancy is higher. Fertility rate's lower. Population growth is more stable, and most of the population is urban. So this is cluster 1, right? And this makes a lot of sense. You can see it's this cluster here. It's got Australia, North America, United States, Spain. And I mean, if you looked at cluster 3, you would basically see only electricity access a lot lower, a lot more renewable energy, which is surprising, much less CO2 emissions. So you can see this 3rd cluster, they're really producing a lot less CO2, less access to internet, etc. And that's what we sort of would imagine would be the 3rd world countries, right? So if I now plot this on a map, this is basically the cool part, and this is sort of the end of the small analysis we've done on all of this data. You'll see, here we go. Here are the 3 clusters we're talking about plotted on a map. And you can very clearly see sort of, I guess, what we think are 1st world countries in blue, 2nd world countries, and 3rd world countries. And this is all just based on that Excel sheet. And, you know, like, I didn't think anything to do with 1st, 2nd world, and 3rd world countries until, like, I created this plot, and I was like, wow, maybe this is how the UN actually categorizes 1st, 2nd, and 3rd world countries, like using techniques like this. I mean, they have to somehow make the distinction. So yeah, it's it's quite an interesting, and this is the culmination. Like you see 3 distinct clusters, and we saw the averages in these 3 clusters. Cluster 1, obviously, much higher GDP, a lot more CO2 emissions, and that's what we expect basically. Europe, America, Australia, Africa, obviously, sort of third world, and then it seems like South America, Asia, sort of more second world. Yeah, guys. So it's a small script. It's like 180 lines, but it's super cool, and it shows you, you don't need that much hardcore software to actually be able to do some cool unsupervised learning analysis. And this is unsupervised learning analysis because we are trying to just find some meaning and structure in the data. And from our goal of looking at all the countries, we've been able to sort of better categorize countries based on their similarities. And that's simple.
Super fascinating. So much more helpful to kind of understand data with those visualizations that those libraries provide. If someone wants to kind of dabble with this and do something similar, where would you recommend finding these data sets? Or is there kind of like a go-to?
Oh, that's a good one. I would say Kaggle is really awesome. So, I mean, this is probably more for like supervised machine learning. But Kaggle.com, I stopped sharing my screen, right? Kaggle.com is like a data science website that's got loads of data science competitions. It's got, yeah, let me just share my screen. This will actually explain it better. So Kaggle is a lot of fun. You'll find code and data for data science work. There's over 50,000 public data sets. And on all of these data sets, people also publish their like code notebooks. So like mine is essentially the country data set and my code notebook, which does everything. People publish their notebooks as well that you can then play around with. And you can see our financial tweets, face detection images, Star Trek scripts, avocado prices. I mean, the data sets are a lot of fun, and like the stuff you can do with them are crazy. I mean, how cool is this? An avocado price data set. there's lots of really cool stuff you can do. Yeah, man. So I would definitely say, like, if you have a lot of free time, playing around in Kaggle is so cool.
Before we knock off and anyone else wants to ask questions, I just did notice that there's 2 comments from Jonas. One is, what is this program? And I think it's R.
What is that program? So that is R, the good old stepchild of data science, I guess. The less popular than Python, but still pretty cool. Basically more for statistics, but yeah, R and RStudio, which runs R. You'd like to see some Julia programming for visualization in the future. Okay, sick. That would be cool. Whoever wants to do that, tackle that for sure. And yeah, guys, that's cool. I think data viz and all of this stuff is like so underrated and cool. I mean, it's like takes a lot of time and effort, but if you have like some really good data viz packages and you get like really dirty with creating data visualizations, at the end of the day, that's like what 90% of what people see, like not the back end stuff. And they're like froth for really cool, like interactions, visualizations. So that's something I'd like to spend more time on, but we'll probably never get around to be honest. Sick. Thanks everyone for tuning in. Any other questions? I think that was pretty straightforward. It's a little demo.
So when are you going to do a big data visualization for wildcards, John?
Yeah, that is a good question. That would be very cool. There's such cool libraries, man. I've looked around and done some dabbling, but probably never, to be honest. But maybe we should actually. Dashboard.
Yeah, that's not a good answer.
No, we'll do it.
Yeah.
We'll do it.
Yeah, we need more data first. We'll grow.
Awesome, guys. Cool. So any requests or thoughts on what we want to do next week? Has anyone got anything cool to share or do?
Well, in 2 weeks.
In the next 2 weeks,
we do this every 2 weeks.
Maybe you build that dashboard for us, Jason, and demo it, the visualization.
The wildcards dashboard.
Yeah.
Yeah, one day.
One day. All right, cool guys. Thanks so much. John,
Awesome.
that was super interesting.
Cheers, guys.
Thanks, John. Cheers.
Take it easy.
Peace.
Ciao.